All right, so we're going to do hexadecimal chart. The reason we use hexadecimal is because graphics on computers uses hexadecimal. We look at the red, the blue, and the green. Alphabetically backwards, yes. Red, green, blue. And I wanted to make sure you guys knew how to make the chart, how to do the conversions from hex to binary to decimals. So we'll start again with how do you make a hexadecimal chart. We start off by, it's a 4-bit binary conversion. So any number to the 0 power equals 1. Any number to first power equals
2.
Itself, yes. You got to speak up. I can't hear you.
All right.
Any number squared, 2 times 2 is
4.
4. 2 times 2 times 2 is 8. Right. All right. So hexadecimal means it's base 16. So we're going to have 16 numbers, and the first number with computers always starts with 0. So our 4 bits that we use in binary to represent the hex value of 0 is written like this. So there's no 1s, there's no 8, there's no 4, there's no 2, there's no 1, and it's equal to 0. Okay? So if I want a 1 for the next number, I need to put a 1 under the 1. There's no 2, there's no 4, there's no 8. Okay? And if I want a 2, please stop, whoever's doing that. There's no 0 under the 1, there's a 1 under the 2. There is a 0 under the 4 and a 0 under the 8. So the only place that we have a 1 is under the 2. So if I want 3, what would I have? Where would I put the first 1?
Second.
Where?
First.
So under the first, and then where else? That would give me 1. I want 3.
0.
So I need 1 under the 2, so I can add those 2 together.
It's going to be 0, 0.
And then 0, 0, which would give me 3. And if I wanted 4,
1.
Bless you, please.
I don't want an 8, I want a
1.
1. I don't need a 2, and I don't need a 1, right? If I want 5,
1.
I don't need an 8. I need a 4,
0.
and I need a 1, right? So 4 plus 1 is 5. And if I want 6, what do I need?
1.
Just tell me what numbers I need.
4.
I need a 4 and a 2, right? And if I want 7,
4.
4.
4 and 2 and 1.
all right, so that equals 7. Now that's going to give me my first 8, right? Now I need my other 8. So I'm going to do the same thing again. 2 to the 0, 2 to the 1, 2 squared, 2 cubed. 1, 2, 4, 8.
8.
So the only place I need to put a 1 is under the 8. And then if I want 9,
8. 1.
all right. So the whole point of hexadecimal is to represent 0 to 15, but only use 1 bit to represent it. So at 10, we want to use A, because it was the first available thing we could come up with that everybody would know had an order behind it. So A is the equivalent of 8 and adding 2 to it for 10. So it's 1, 0, 1, 0. and 11 would be a B, and that's equivalent of 8 plus,
Oh, 1,
8 plus 2.
wait, I'm lost. What's it?
8 plus 2 plus 1, that gives me 11, and then I want 12, which is C,
8 and a 4.
which is 8, I want to write an 8, 8
And 4.
and a 4, no 2s and no 1s, right?
Right.
And then 13 is 8 and what?
8 and a
2,
1 and a 1. 4 and a 1. 8, 2.
So,
2 and 1.
8 plus 5, so it's a 4 and a 1, right? Alright, and then the E is
8,
14.
8, 4, 2.
Yeah, 8
So it's 8 and 6, right? So 8, a 4, and a 2. 8 plus 4 is 16. It's 14, right? Alright. Alright. So 15 is going to be,
8 and 4 and 4. Wait, no, what?
it's going to be 7 plus 8, so it's 1, 1, 1, 1, right?
Right.
Okay. So I always like to point out, once you get the chart up, that you can, there's a pattern. You all see the pattern, right? So what's the pattern?
It adds about 1 each time.
Adds by 1 each time. No.
Wait, what do you mean the pattern?
Like under the ones, it changes every one, right? See the pattern? And then under the 2, it's 2 zeros, then it's 2 ones, and then it's 2 zeros, and it's 2 ones. That's the pattern. See it? And then under the 4, it's 4 zeros, 4 ones, and then 4 zeros, 4 ones, and then for the 8, it's 8 zeros and 8 ones. So if you were in a hurry and you want to just throw up the chart, the things that you want to check is that you always have 0 as the start. You always end in F. And 10 is 1, 0, 1, 0. Okay? 10, 10. See it? All right. Now, we say that we use it to do conversions because we are expected to do it on certification tests, as well as understanding the intensity of a color. By converting it to the decimal value, we relate better to it. All right? So, I always like to start off with teaching a fact on binary numbers. So when I go to binary, I usually go 8 bits. So you go 2 to the 0, 2 to, oh, I can't use this color. This is the one that's not showing up. 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. So that's, any number to 0 power is?
0.
Itself.
Yeah.
Any number to the 0 power is?
0.
1.
Itself.
Any number to the first power is?
Self.
Itself. And that's 4. It doubles 8, 16, 32, 64, 128. Got it? So, if I had a 1 and a 1 here, which would be a 2 plus 1, that would give me what?
3.
If I add those together, it gives me 3, which is 1 less than the next number. And if I put a 1 here, I'd add 4 plus 2 plus 1, which would give me 7, which is 1 less than the next number. And it goes on like that. So if I were to say convert 127 in decimal, right, to hex, you could actually sit here and look at, well, that's 128. So if I put all 1s there, that's 127. It's 1 less than the next number. You see that? And if I wanted to make it 123,
It'd be.
I just took a 4 away, right? I went from 127 to 123. I just draw a 0 where the 4 is. See how that works? Yes? All right. into hex, I want to go 4 bits going in this direction. So 1, 2, 3, 4, and then 1, 2, 3. Wait, I only got 3. What do I do? Well, I can write zeros in front of $5 all day long. It doesn't change the value. So I can write a 0 here, and I'm not changing the value. If I went in the other direction, I would end up changing the value, right? All right, so I look on my chart. 0, 1, 1, 1 is 7. It's right here. And then 1, 0, 1, 1 is 11, which is B. So I would write that as hex. 7B hex. See how I did that conversion?
Yeah, this is. Oh.
Okay? So now, if I wanted to go backward and say I had a 7 in hex,
Be 10 and 7.
I would write 1, 0, 1, 0 for the A, right? And then the 7 would be 0, 1, 1, 1. And then I would just convert this based on these values. So I have a 128, I have a 64, I have 7. So that gives me 167. That's 160 plus 7, right?
Yeah.
Okay, so what else can I do here? Okay, so hexadecimal is actually base 16, right? So if I had A7, we said A is 10, right? This is 16 to the first power. Let me write it underneath. 16 to the first power is 16 to the 0 power. Any number to the 0 power?
1.
1. So this would be 7 times 1. And any number to the first power?
6 itself.
Itself. So this would be 10. A is 10 times 16. So that's 160 plus 7, 167. Did you all see how I did that?
That's really cool.
All right. Thank you.